Welcome back to All This Math. This is Professor Parker, and today's lesson deals with like Algebra 2. Actually, you might see this in Algebra 1, but it deals with parabolas, right? It deals with parabolas, the graphs of parabolas, and also the equations that represent the parabolas. Now, a parabola is a shape that looks like a U, basically. It looks like a U. It might might be graphed like this, or it could be downward facing, so it could be like this. Could be sideways facing, sometimes it's like this or it's like that. But the ones we're going to deal with right now are written in terms of X. So the ones that's in terms of X, meaning you got your X squared and your X, together on one side of the equal sign, they're going to be either upward facing or downward facing, like a roller coaster. You know what I'm saying? Kind of like a roller coaster. All right. Before we get into this, I want to talk about this sweatshirt. This is my Prairie View A&M sweatshirt. And whenever I think of Prairie View A&M, I think of two people. All right, two people that are significant to me in terms of like influencing my political development and my political awareness. One is Jacob Carruthers. Jacob Carruthers taught at Prairie View A&M, which is located in Texas. It's a historically black college. He taught there in the early 1960s. He taught political science at Prairie View A&M in the early 1960s. And Jacob Carruthers also was one of the founding members of ASCAC, which is the Association for the Study of Classical African Civilizations. He was a co-founder along with Nzinga Heru, Dr. John Henrik Clark, Dr. Joseph Ben Yakinen, Asa Hilliard, I believe Milan Karenga, and I might be leaving some other people out. I believe Leonard Jeffries as well. So he also was a writer, in addition to being a teacher. And I pulled out a couple of his texts. Here you have The Irritated Genie, which is about the Haitian Revolution. Definitely learn about the Haitian Revolution. All right, this is a good book to introduce you to the Haitian Revolution if you have not been as of yet. Also, another one of his books entitled Medu Neter, Divine Speech. Medu Neter, Divine Speech. All right. And also Intellectual Warfare. Intellectual Warfare. And of course, this information is more relevant than ever here as we stand here in 2023. All right, trying to navigate this society and this world that we live in right now. All right, so that's one of the people, Jacob Carruthers. The other person was Sundiata Acoli. The other person I think about when I think of Prairie View A&M is Sundiata Acoli, whose birth name was Clark Squire, I believe. And he was a member of the Black Liberation Army, and he was actually with Assata Shakur in 1973 when the New Jersey State Troopers attempted to assassinate them. Unfortunately, Malik Zaid Shakur did end up being murdered on that day on the New Jersey Turnpike. But Sundiata Acoli was a mathematician. He had a math degree from Prairie View A&M in college that he earned. So when I think of Prairie View A&M, those are two brothers that I definitely think of. Sundiata Acoli was also a political prisoner. He was recently released, I want to say in 2022. I need to look more into that and find out more information about that. But those are two people that are connected to historically black colleges that I think we should understand. I think we should understand and we should know about as well. All right, so now let's get into this algebra, take a look at what our instructions are, and figure out a game plan for how we're going to answer this problem. So this problem says to put in vertex form. So first we got to know what vertex form is. But put in vertex form and then convert to standard form. So it's two things we got to know, right? Because when we deal with math, a lot of times you'll get a lot of terms and concepts and ideas kind of thrown at you. If you don't know what the terms mean, then how you going to do the problem? So first we got to know and be clear about what is vertex form, all right? And then we got to be clear about what is standard form. What does that mean, all right? Now, vertex form is essentially, it's a way that you write an equation. Now, you can write equations in different ways. Now, an equation is just a name for a picture. All right, it's a name for a picture. The graph is the picture. The graph is what it looks like. But the equation is the name of it. So that way okay, this equation includes all of the information, all the points on this graph. This equation indicates how wide the graph should be, how skinny it should be, how lengthy it should be, how stretched it should be, how compressed it should be, how low it should be, how high it should be, whether it opens up, whether it opens down. The equation has numbers in it that give you all that information. That's all an equation is. Equation is just a name, right? Within the name, it's like, okay, like everybody got a name. Like my first name is Akil. Akil means wise or one who uses reason. That gives you an indication as to what type of person I am if I live up to my name. So an equation is just a name for a graph, right? Or a name for something that's expressed in mathematics. All right, so now let's first write what we call the vertex form, the general vertex form. It looks like this: y equals a times x minus h squared plus k. All right, that's vertex form. So if you don't have this memorized and you're in a class where you're responsible for this, you should memorize this ASAP. All right, y equals a times x minus h squared plus k, or the quantity of x minus h squared plus k. All right, now every one of these letters means something. It represents something. Every one of these letters got a meaning. Now, x and y are the coordinates of some random point on the parabola. Now, a parabola has an infinite number of points, billions and billions and trillions of points. All right, it might not seem like it, but they do. All right, so x and y are the coordinates of one random point. In this particular example, we're given the vertex. Now, the vertex is the lowest point on the parabola if it's opening up, or the highest point on the parabola if it's opening down. So the vertex is either the highest point if it opens down, if the parabola opens down, or the vertex is the lowest point if it opens up. All right, this is our vertex. This is the coordinates of our vertex. 3, -2. So my x value is 3, my y value is -2. Now you might be saying, well, but if the vertex, like, how come that's not x and that's not y? Because the vertex is a special point. So the vertex is so special, it's got its own letters for its coordinates. So we don't even use x and y to describe the vertex. To describe the vertex, we use h and k. H and k. So h and k represent the coordinates of the vertex, right? Whereas x and y represent the coordinates of some other random point. I just call it p for point, right? So x and y, again, this is critical. X and y represent the coordinates of some random point on the parabola, whereas h and k represent the coordinates of the vertex. So let me actually write that down because that's very important. All right, so this is my h, this is my k. All right, this is my x, this is my y. All right, now the only thing I don't know is a, but I can solve for a, right? I can solve for a, and you have to solve for a because we can't just assume that a is 1 or a is 5 or a is 32. We can't assume. We have to use algebra and solve for a. So what we're going to do in order to solve for a is, right, because we can't write the equation in vertex form unless we know what a is. All right, so we got to figure out what a is. So this is how you figure out what a is. You're going to plug in every number that you know, and then because a is the only variable that you don't know, right, we're going to solve for that. So my y is 3. So I'm going to rewrite this equation. I'm going to replace y with a 3. Bring my equal sign down. I don't know what a is. So I'm going to write a again. Then I write my parentheses. I know what x is. My x is 2. Because remember, the random point is where you get your x and your y from. The random point, the extra point they give you in the problem, is where you get your x and your y from. You get your h and your k from the vertex. The h and the k is the vertex. All right? So now, this is where you got to be careful. Because h is 3, there's a minus sign here, right? So you got to put -3. Now, this is a +3. So looking at this, it makes it look like the 3 is negative, but the 3 is not negative. The 3 is positive. But remember what the original formula looks like. The original formula got a minus sign in it. So basically, what you do in this situation is you might think of it like this. Whatever your h value is, it's going to be the opposite inside the parentheses. So dig this, right? If h was -3, then that means it would have been a +3 in here because it would be minus a -3. And what happens when you have a double negative? When you have a double negative, that becomes a positive. So it will become a +3. So the actual coordinate is +3, but in the equation, it looks like a -3 because we're following the form. We're following the formula, basically. All right, so that's always going to be the case. So just keep that in mind because that's something that might trip you up a little bit in the future. But don't let it, though. You bring the exponent down. Boom. And then k is -2. Now, k is what it is. So if k is -2, I could either write plus -2, or I could just simplify it and just write -2. Because adding a negative is the same thing as doing subtraction, right? Adding a negative is the same as doing subtraction. So I'm going to just do -2. So now my whole goal is to solve for a. I'm trying to figure out what that is, all right? So now I got to simplify everything I can and then use rules of algebra to solve for a. So the first thing I'm going to do is follow order of operations. Inside the parentheses, I'm going to do my 2 minus 3, which is -1. Everything else, I bring it down. And then I got -1 squared minus 2. And then I use the exponent. -1 squared is +1. So now I got 3 equals A times 1 minus 2, right? And what's A times 1? A times 1, anything times 1 is that thing. So A times 1 is just A. So I got 3 equals A minus 2. And now I'm trying to get A by itself. All I got to do is basically just, wait, hold on a second. 3 equals A minus 2. That was -1. Yeah. Ain't gonna square +1, A minus 2, boom, boom. Okay, yeah. So this is gonna be, I'm trying to get A by itself, so I'm gonna add 2 on the right and add 2 on the left. Boom, boom, 3 plus 2 is 5. 5 is equal to A. So my A value is 5, right? Let me see something here. Yeah. Sometimes I be doing so many of these problems. I thought I did this problem already. And I thought my A value was +1. That's why I had to step back for a minute, like, whoa, hold up. You know, but actually it was 5. You know what I'm saying? So, all right, so look, my A value is 5. So now that I know that my A value is 5, now I can put it in vertex form. I can't put it in vertex form unless I know what my A value is, right? Now, dig this. When you write your equation in vertex form, you need a number in the place of A, H, and K. A, H, and K. A, H, and K. Like OC. A, H, and K, right? So A, H, and K. Numbers. They need to be numbers, right? So think about it like this. OC needs numbers. OC needs numbers. All right? So A, H, and K need to have numbers in the place of them. You keep the Y and you keep the X. You keep the Y and you keep the X. So when I write my equation in vertex form, it's going to look like this. It's going to say Y equals 5 times the quantity of X, because I keep the Y and I keep the X, minus 3, because my H is still 3, minus 3 squared. My K is still -2. So I could write plus -2, but nah, actually you shouldn't write plus -2 because you should simplify it. You should make this a -2. So this is vertex form. This is vertex form. And notice what I did. Let me recap. I keep the Y and I keep the X. I'm just basically rewriting this by replacing A, H, and K. But I couldn't do it up front because I didn't know what A was. So we had to do this work to figure out what A was. So we used what we got to get what we want. We already knew what Y was, X was, H was, and K was. We used that information to figure out what A is. And we used algebra and we figured out that A was 5. All right. So now we can write the equation because we can't write the equation until we know what A is. So when you're doing math, you should always know why you're doing what you're doing. All right. Don't just memorize the steps because eventually you're going to forget a step and you're going to be like, but if you know why you're doing it, if you know the purpose, then that's going to help you to remember what you should be doing. All right. So we needed to write the equation in vertex form. Vertex form requires that we need numbers for A, H, and K. We already knew H and K, but we didn't know what A was. So we got to figure out what A is. Once we figured out what A was, now we can write the equation in vertex form. Now, then it says convert to standard form. Now, this is what standard form looks like. Standard form looks like this. Y equals AX squared plus BX plus C. All right? That's standard form. Vertex form, standard form. Vertex form, standard form. Standard form basically has the coefficients A, B, and C, and they go in alphabetical order. All right? Now also think about, let me back up a little bit. Think about why these things are called what they're called. This is called vertex form because you can look right at the equation and immediately tell what the vertex is without doing any math, right? You look right at it and say, okay, that's my H and that's my K. So I automatically know what the vertex is just from looking right at it. Just like with slope-intercept form, if we're dealing with linear equations, it's called slope-intercept form because if I look right at it, written down, y equals mx plus b, I can immediately tell what the slope is and what the y-intercept is. That's why it's called slope-intercept form, right? Everything in math has a name for a reason. So as you learn different math concepts and different math terms, make sure you understand why is it called that, all right? This is called vertex form because I can look right at it and tell what the vertex is, that H and that K. That's my X value for my vertex. That's my K value for my vertex. So if I wanted to graph this, I would go plot this point. That's my X value. That's my Y value. But it's not called X and Y because it's a special point, right? The vertex is the most special point in any parabola. I mean, somebody say the y-intercept is important too. All right, that's cool. It is. But I think the vertex is a little more important because the vertex is where it stops going up and it starts going down, or it's where it stops going down and starts going up in the graph. All right. So now, This is standard form, and I guess it's called standard form just because it has the coefficients represented by the letters A, B, and C, going in alphabetical order maybe. I'm not really sure. But at any rate, how do you convert this? All right. Now, the way to convert it is basically multiply all this out, right? Using the order of operations, of course, but multiply all this out. All right. So we're going to do, we got 5 times the quantity x minus 3 squared minus 2. The first thing I would do, because order of operations says for us to work out whatever in the parentheses first, right? We can't work out x minus 3, right? Because those aren't like terms. I can't subtract 3 from x because I don't know what x is, right? So we go to the next thing, the exponent. We deal with the exponent. This exponent 2 tells us that we need to do x minus 3 times x minus 3. So that tells us what to do. We have instructions, right? The equation gives us instructions. It tells us what to do. And if we follow order of operations, we know what to do first. We know what to do second. We know what to do third and all that, right? So check this out. Let's do this. Let's say it's going to look like this. Matter of fact, let me switch the color up. Let me go blue, right? So we got y is equal to 5 times x minus 3 times x minus 3 minus 2. Now notice how this changed into this, all right? Make sure you understand the progression. Always understand the progression in any math problem, right? One step to the next. This is the same thing as this, because what does that exponent mean? That exponent means that I'm doing x minus 3 times x minus 3. And that's what I wrote right there. So now you got to know how to multiply binomials. I like to use the FOIL method. A lot of teachers use the FOIL method and teach the FOIL method, meaning first times first, outer times outer, inner times inner, last times last. FOIL is an acronym which gives you instructions on what needs to be multiplied. FOIL, first, outer, inner, last. All right, so when I do that, what I'm going to have is this. Y equals 5 times the quantity, and keep it in parentheses, I'm going to have x squared minus 6x plus 9 minus 2. All right, now I ran through that. I didn't really go through it step by step, but this is also a special product. So I already know what it's going to be, right? But anyway, if you do FOIL, it's x times x. That's where the x squared came from. Then it's x times negative 3. That's negative 3x, right? And then it's negative 3 times x. That's another negative 3x. What's negative 3x minus 3x? Negative 6x. That's where the negative 6x came from. So when you're sitting in class, right, and your teacher's at the board doing problems, make sure you know where every number came from. Make sure you know where every letter came from, every variable came from, every exponent came from. Make sure you know, right? Don't just be sitting there writing everything down. Because you sit there and write everything down, but you don't know what you're writing, then it's almost pointless, right? And a lot of people think, well, I'm going to just copy everything down, and then later on, I'm going to figure it out. You're probably not going to figure it out. That's not realistic. What you need to do is, and I say this with love, get out your comfort zone and raise your hand. Ask questions. Where did this come from? Where did that come from? Where did the 2 go? Where did the 8 go? All right, you got to ask those questions. You got to be an active learner and really ask questions in class. Don't be embarrassed. All right. And if it still don't make sense, if your teacher can't explain it adequately, just come to this channel and I got examples for you. All right. So now, where did the 9 come from? FOIL method. Negative 3 times negative 3. Positive 9. Boom. All right. Now, so we got this. So we see where this came from. We just multiplied x minus 3 times x minus 3. All right. So now, multiplication. We got multiplication and subtraction. Multiplication and subtraction. So I'm going to distribute this 5. Right? So this 5 is getting given to the x squared, to the negative 6x, and to the 9. So now I got y equals 5x squared minus 30x plus 45. And then I got minus 2. And I don't need the parentheses no more. I don't really need them. I just needed the parentheses to separate this from this. But since I distributed the 5, I don't need to separate them no more, because what I'm about to do is this. I'm going to combine like terms. The 45 and the negative 2 are going to get combined. I'm about to be finished. This is my last step. It's going to be y equals 5x squared minus 30x plus 43. That's my final answer. So look, this, I know this seemed like a lot, but it ain't really difficult once you know how to do it, right? So this is the equation in Vertex form. Let me slide over here. This is the equation in Vertex form. Y equals 5 times the quantity x minus 3 squared minus 2, right? The equation that represents the parabola that has this information in it, that has this vertex and has this as one of its random points, So think about how amazing that is, though, for a moment. Just ponder that for a minute. All you need is the vertex and some random point, and you can figure out the whole equation. That's actually kind of dope, though, when you think about it, right? You know, it's kind of like you could figure out like somebody's name just from knowing like their birthday and I don't know, their favorite color. And then just with that little bit of information, then you could just imagine you could just figure out somebody's whole name, right? That's what we just did here, basically. We found out the equation of this parabola, right? The equation of this parabola, and then we flipped it and then rewrote it in standard form by just using arithmetic and other rules such as the order of operations. We multiplied, binomials, and then we got here. So this is our equation in vertex form. This is our equation in standard form. And I definitely suggest you go get some practice. Practice with problems like this. This is a really good problem. I did a video on this because one of my students that I was tutoring last week, this was one of his homework problems, and I liked this problem. When he showed it to me, I was like, yeah, I got to do a video on this. I like this because of what it requires, right? It really requires you to bring forth a lot of skills. And I like to do videos where you got to bring forth a lot of skills. So yeah, so we brought forth a lot of skills, but you got to practice these, right? So go find some problems like this, or you can actually make up problems, right? Make up a vertex, make up a random point, all right? Write it in vertex form, solve for A. Remember what we had to do. We had to solve for A, right? And then write it in vertex form. We used all the information we had, these 4 numbers, in order to solve for A. Use algebra for that. Then we used algebra, arithmetic, and whatnot to convert it from vertex form to standard form. See? And this is my ax squared. This is my bx. And this is my c. Right? Ax squared plus bx plus c. All right? And we're done. All right? So go get some practice on these. Remember, if you're not familiar with Prairie View A&M University down in Texas, look them up, learn about them. If you wasn't familiar with Jacob Carruthers and his work, look him up, learn about him. If you wasn't familiar with Sundiata Kohli, look him up, learn about him. All right? And also the communities that those brothers were a part of. All right? And are a part of. All right? Peace.